Hello. Thank you for coming. My name is Steve Judd, and I work for a cloud-native consultancy called JetStack Consult. You may have heard of JetStack if you use Cert Manager, but I work on the consulting side. So I spend my time helping companies mature their use of cloud-native technologies. And quite a lot of the time that involves Kubernetes and how to run it better. However, over the last year or so, I've realized that there are other ways of running containers besides on a Kubernetes cluster, and actually they have some benefits. So really what I'm going to talk to you guys about in this talk is alternative ways of running containers that require significantly less effort than managing Kubernetes clusters. Before I dive into those alternatives, I just want to kind of recap where we're at perhaps with running Kubernetes clusters and the challenges there are in doing so. And this isn't just my personal experience, it's because I've worked with loads of customers of all sorts of different sizes who are getting to that point where they've been running, even those that have been running Kubernetes for several years, and they've realized that, hey, there are a bunch of challenges that are kind of inevitable given the complexity of Kubernetes. So one of those challenges, for example, is day two operations. So I'm talking about the constant grind of updating your Kubernetes clusters and updating the add-ons in those clusters. You probably already know that Kubernetes come out with a new minor release every 3 months, and even if you're using a managed service from GCP or from AWS, there is still some toil work involved in continuously upgrading your clusters. And then, of course, on top of that, you're probably using add-ons like Prometheus or Cert Manager or Nginx Ingress or something. They also have their own release cadence, which you need to kind of keep on top of. And then clearly, as your number of your clusters increases, that increases the amount of toil work you're doing on keeping on top of these upgrades. Next, as you know, Kubernetes is a very feature-rich platform. It's got a lot of really cool stuff about it, but that equally means that it's sort of the threat vectors are equally as broad. Kubernetes has a lot of configuration for doing, security configuration, but by default, a lot of that's switched off. So you have to have a pretty good understanding about how to switch on these features, whether this be at the sort of namespace level, pod security specifications, ingress into the cluster, access to the API. Thirdly, and this is one that I've kind of hinted at already, is just the sheer complexity of Kubernetes. The learning curve for Kubernetes is frankly quite steep. And if you're onboarding new engineers, or perhaps you're trying to get, let's say, developers involved, then they have to go through much of this learning curve as well. And then finally, yak shaving. If you're not familiar with yak shaving, well, go and Wikipedia it. But the point is that just to get a service up and running, perhaps one that serves out a website across the internet, there's quite a lot of tasks that you need to put in place or you need to achieve for that to happen. Once you've got your built container, you've got to create the deployment spec, the pod spec, the service spec, probably the ingress spec, create a load balancer, create your certificates. So there's a whole bunch of these things just to get that service up and running. So as I said, there's quite a lot of work involved with Kubernetes just to sort of get it to do quite a lot of, often quite simple tasks, shall we say. But here's the thing, up until possibly a few years ago, you didn't really have much of a choice if you wanted to run containers. Now I know that there are alternatives, Nomad, Mesos, Docker Swarm, but let's be honest, Kubernetes kind of won that battle, so realistically, you didn't have much choice. However, over the last year or so, let's call them serverless container hosting products, have matured to the point where I genuinely believe that they are a viable alternative for hosting a large number of container use cases. And really that's what I'm about to talk about in the rest of this talk. So I'm going to be looking at the serverless container hosting alternatives from the different public cloud providers. So Cloud Run from GCP, which is, to be honest, the one I know best. Fargate on ECS from AWS. And then finally, Azure have something called Container Apps. And what I'm going to go through to start with is the sort of general features that you can expect to get from each of those different products, because broadly speaking, they're the same. And then later on in the talk, I will go through where some of the differences are. So these are the sorts of typical features. You can take a container, a Docker image, or an OCI image, and give it to one of these services, and it will run it for you. And if it's a web service, then it will provide you with mechanisms to allow you to ingress to that service. You can also, so you could run like a web service or a backend API. You can also run scheduled jobs. So for example, I don't know, you've got some sort of container that does work like image processing or data processing, and you want to do that on a scheduled basis, then these tools will do that for you. And then finally, a lot of them will also handle event kind of processing as well. So if you've got some sort of pub sub or event arc type environment, you can use the containers to sort of get the pub sub topic messages come through and process those. The way that these services are costed is typically on the amount of CPU and memory that is used while the requests are being processed. So even if you've got like a load of instances that are taking up, I don't know, a gig of RAM and 5 CPUs, for example, they will only charge you for the time that your request is being processed, with some nuances there, which I'll go into. But the point is that that means that you can therefore scale. Basically what happens is that the instances get scaled down to 0 when they're not having to process any requests. And at that point, you're not paying for anything. And then as soon as a new request comes in, then an instance will get instantiated for you and process the request. And during that time, that's when you're being charged. As I've already sort of slightly hinted at, auto-scaling is something that comes as standard. So certainly with Cloud Run, for example, you specify how many concurrent requests each instance of the container can handle. And then as soon as that container starts getting close to that number of kind of current requests, then Cloud Run will step in and start scaling out to have more instances which are automatically added to the sort of load balancer, and that's how the auto-scaling works. Then once those requests have been processed, then if there's no more work for that container to do, it will start scaling them back down again. So this happens automatically. And then probably the final thing that I wanted to mention is that when you create these kind of container workload instances or services, then you can supply more than one container in each instance. So for example, you might have some kind of sidecar pattern that you want to use. So you've got your main container that's doing the work, but you might want to have a proxy sidecar to handle database connections, or you might want to use a third-party observability agent to send data off to Datadog or wherever. So those are also possible with all of these sorts of products. So that's kind of an overview of the sorts of features you can expect. From a non-functional perspective, How does it look from a security and performance and observability perspective? Well, they've kind of got you covered there too. So from a security perspective, these containers are running in isolation. They're running in kind of isolated Linux sandboxes. So as soon as a new instance gets provisioned, it's in a brand new, fresh sandbox. Once that instance dies, so does that kind of Linux microcontainer VM thing die as well. The consequence of this, by the way, and this is perhaps a constraint with using these systems, is that you don't have the ability to have a permanent file system. So you've got ephemeral file systems, but there is no facility for like the equivalent of a persistent volume or a persistent volume claim. You can, of course, write off to things like S3 buckets or Cloud Fuse, something like that. But as I said, you don't have the high-performance local permanent file system available. Certainly with Cloud Run, by default out of the box, all of the traffic is encrypted, and it provides you with TLS certificates for the URL that comes from the public internet through the load balancers. And you can choose whether you want to allow anonymous access to your services or whether you want to provide some level of IAM-based authentication using, let's say, OIDC or something. From a monitoring perspective, all of these services by default send their telemetry data and logging data to whatever the cloud provider's observability solution is. So in the case of GCP, it sends it all into cloud operations by default. And they don't charge you extra for this. This is just part of the price. And then finally, from a performance point of view, there are various dials and levers that you can manipulate in order to get better performance. So you can specify the number of CPUs. It's basically you specify the maximum CPU limit, the maximum amount of memory. And as I said, in Cloud Run's case, you specify the maximum number of concurrent requests before the auto-scaling kicks in. They also support service health checks and session affinity. The comment that I've put up there about cold start versus warm start, so this is something to take into account when you're deploying a service, is that, as I said before, you can scale these services down to 0. But clearly that means that when a request comes in, then you've basically got a cold starting service that needs to come up. And depending on what that workload is, that could be a reasonably substantial amount of time. Looking at Spring Boot, for example. If you've got a Java workload, they can take 60 seconds just to get going. So when you've got certain workloads that perhaps take maybe too long to start up from cold, this is where you can choose, rather than to scale everything down to 0, you scale down to something like 1. So you've always got a container sitting there running, waiting for requests. So that's perfectly legitimate, but of course it does mean that you're being charged for the fact that that container is actually running. So I thought at this point it'd be quite exciting to do a demo, because that's always a good thing to do in the middle of a presentation, I feel. The Wi-Fi here is pretty good, so I'm very happy about that. So what I'm going to show you is, I'm going to use Cloud Run, and the reason for that is, as I said, I'm more of a GCP person than AWS, and frankly, Cloud Run is far easier to use than Fargate is. There's far less to set up, but I'll talk about that a bit later. So what I'm going to do is use the GCP console to basically provision a very simple Hello World container. So here I'm just giving it a pretty trivial Hello World type container, web service. And I'll leave it in the US region. And you'll see here the CPU allocation. So there's two types. First, the default is where the CPU and memory are only being used when it's actually processing a request. So you're only going to be charged for that request processing, if you like. You can change it so that where it says the CPU is always allocated. So that means while the life of that container that instance is running, then you will be charged, but the CPU is allocated. The reason this is quite useful is if you've got some kind of post-request processing that needs to be done by that workload, then using that option means that you'll get the CPU allocated for doing that. Moving down to the authentication. As I said before, you've got these different options. So I'm going to, in the authentication, I'm going to allow unauthenticated access. But if I wanted authenticated access, then by checking the require authentication, that would mean that I'd need to set up, in Google's terms, I'd set up some OIDC authentication for it. The rest of it I'll just leave as defaults. So this is where you specify the container port. And you can specify certain container arguments and so on. And down here, you can see this is where you specify the amount of memory and CPU, the maximum amount that that workload is allowed to consume. So it's now creating it. So basically, it's pulling the container, instantiating the workload, and hopefully within a few seconds, we shall see a working service. So there it is. So we've got a working service. If I click on so you can see there that Cloud Run provides you with a default URL, which is already TLS enabled. You can provide your own custom URL if you want to, but out of the box, you've got a sort of standard URL you can use. In terms of the actual Cloud Run kind of dashboard you get a set of the metrics or the telemetry dashboard, which comes out of Cloud Operations. So you can see that running. You can see the logs. So this will provide you with the workload logs as well as the kind of event logs for that particular service. And then finally, the last thing I just wanted to kind of draw your attention to is, I don't know if that's big enough to see, but at the top there, hopefully you can see that it's using a Knative API for doing the actual YAML manifests. And I'll talk a bit more later on about the significance of using Knative. Cool. So I've talked you through the features of products like Cloud Run and Fargate, and I've talked around things like the performance and the security that you can expect from these sorts of products. And this, don't forget, is all out of the box. You're not having to configure any of this stuff. So moving on, how do you deploy these services then? What kind of deployment mechanisms are supported? Well, I've shown you how to do it using the console, although, frankly, you're not really going to be doing that very often, certainly not in a production environment, I hope. More realistically, you're going to be using some kind of IAC tool, probably Terraform. And what I might show you later on, if I've got time, is that one of the things that I did was take a microservices application that was developed for Kubernetes and ported it over to running under Cloud Run. And I used Terraform to manage the actual deployment of each of the services. And although I'm not the biggest fan of using Terraform for deploying into Kubernetes clusters, I think for things like Cloud Run and Fargate, it actually works really, really well. It's quite an effective way of doing kind of deployments if you want to go down that route. And then the alternative is you can use some kind of GitOps style of deployment. So in the case of GCP, you can create your Knative Cloud Run service manifests, push them into a Git repo, and that Git repo is synced with Cloud Build, which you can then use to actually do the deployment into the Cloud Run environment. So that's ways of deploying things into your different Cloud Run environments or Fargate, whatever. In terms of the different deployment patterns, well, they support all the kind of ones that you'd hope they would. So by default, what happens is when you deploy a new version of a particular Cloud Run service, then as soon as that Cloud Run service has kind of got up and running, all of the traffic from then on by default will go to that new version. That might not be what you want. You might only want to send some of the traffic to that new version and let the rest of the traffic go to the previous version, a canary deployment, if you like. That's supported. So you can specify like the percentages of traffic that go to different versions of your Cloud Run service. Or in fact, I think it works with Fargate as well. And then finally, rollbacks is as simple as deleting the latest version of the service. By doing that, by default, the previous version will get automatically instantiated, and all new requests will go to that previous version that's now been reinstantiated for you. So that's hopefully given you a flavor of what Cloud Run and Fargate and container apps will do for you in terms of allowing you to run or host container workloads without that much effort, frankly. So that sounds great in theory, but where are the constraints? What does that mean in terms of the types of workload that are actually going to be viable and practical for using these products? Well, I think it's quite a broad set of use cases. So web services, ones that come in either from the internet or, as I said, react to events from pub sub queues or whatever. That's a pretty good way of doing it. So, you know, your standard sort of web services or back-end APIs. Scheduled jobs, where you've got work to do, backups, data processing, image processing, so on. That's another good use case. So I think there is quite a broad spectrum of workloads that is well suited for these types of serverless container hosting products. Ones that aren't so well suited, these are the ones that I thought of. I think there are other ones. But basically, if you've got some kind of container workload that doesn't respond well to scaling horizontally, that's not going to be a suitable one. Any workloads that really do require a permanent file system, they're not suitable. So you're not going to be using Cloud Run, for example, to run a database service. And then finally, although you, as I said, you can specify the amounts of memory and CPU, there are maximums. So for example, with Cloud Run, the maximum is at 8 CPUs and 32 gig of RAM per instance. I think on Fargate, it's double that. So you do have some limitations. So if you've got a workload that needs very large amounts of CPU or memory, probably not a good option. And also currently, as far as I'm aware, you don't have a choice about the CPUs or where it's running, apart from the region. So you don't have the option, for example, of TPUs or NVIDIA GPUs or something. Yes, question.
Hi, there's a GitHub project called, in the context of C++ compilation, which can use lots of memory and lots of CPU, depending on how much you think it's a lot. There's a project called Stanford GG that outsources the compilation part to Cloud Run or a serverless component. I haven't actually tried it in anger. I just wondered if you'd come across it and whether you think it's a good idea at all.
I'll be honest, I haven't come across it because my knowledge of C and C++ is so pathetically small, I don't want to talk about it anymore. But I think that's a good use case, to be honest, where you start to, as you call it, outsource some of the compilation work.
Sorry, just to add that, the pre-processing is done locally because it's considerably quicker to pre-process, and then it's the compilation that is the heavy part.
Okay. I can see why that would work. That's quite an interesting. So does that mean that you basically use some kind of HTTP connection to send all of the traffic into Cloud Run or whatever? Is that?
Yeah, you pre-process locally. You send the pre-process code out, and you get the object file back.
Okay. Yep. No, I can see how that would be quite cool. And quite an effective use because you're doing that periodically. So you don't want. You're going to be periodically at random intervals wanting to send some code to be compiled, but it's not something you're going to do on a regular cadence, so you don't need something permanently running to receive that. You just want it there when you need it and can frankly spin up quite quickly, do its thing, and then shut down again. So yeah, I think that's... Yes, 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 because with the way that the scheduled jobs, so I can see how that might set up multiple instances on demand. And then probably what I should have said with the scheduled jobs is that you can run those in parallel as well. So for example, if you're doing, I don't know, let's say loads of data processing, if it can be done in parallel, then you can set up the scheduled jobs to run in parallel as well. Right, so I've kind of talked about the common sort of features that you'd expect to see from these different technologies or the different services from the different cloud providers. There are differences between them. So I'll spend a few minutes talking about what those differences are. By the way, I'm quite a big GCP fanboy, if you hadn't already noticed. So that's the one where I've got most knowledge. But basically, in my admittedly biased opinion, I think it is genuinely the simplest to provision. I showed you in the demo just now, it was literally a case of saying, here's my Docker image, go run. And it is that simple. If you look at AWS, it's considerably more yak shaving. You have to set up the networking, the subnets. You have to define your ECS cluster. You have to set up the firewall rules and the load balancing, which I genuinely was quite shocked because it was like, really? You have to do all of this just because I want to run a container? So I was a bit disappointed, I'll be honest, but it is kind of a one-shot thing. So once you've set all of that up, you can then just provision your Fargate workloads in there. Other things about Cloud Run, it is quite opinionated. So if you can handle that opinion, then great. If you can't, then Fargate's probably a better option because it does give you a lot more things to tweak in terms of the configuration. Also, Google Cloud Run doesn't support like a service mesh. So if you wanted MTLS between your different workloads running in Cloud Run, you have to do this at the application level. So you don't have the equivalent of Istio, for example. And then finally, I guess it only supports one port for ingress. So if you've got a workload that uses multiple ports, then you'll need to use some kind of proxy sidecar to kind of handle the traffic coming in on one port and then spread it out over the different ports to send it to the actual workload container. As I said before, it uses Knative. So you noticed in the YAML manifest for defining a Cloud Run service, it used the Knative API. So Knative is basically a serverless project that runs, typically it runs on top of, so it's a CNCF project that typically is hosted on a Kubernetes cluster. The reason it's quite important or quite significant that they're using the Knative API is because if you decide you've got a bunch of Cloud Run services and you want to run them somewhere else, maybe you want to run them in a different cloud or you want to run them on-prem, then you can do that by installing Knative on a Kubernetes cluster in that other cloud or in that on-prem environment, and then you can use basically the same manifest across all of those different environments. So with Fargate, as I've already said, there's a bit more yak shaving to do in order to get some services up and running. Having said that, it does mean it is a lot less opinionated. It also does support like a network level service mesh, so that's an option, and it also supports multiple ports for ingress as well. In terms of Azure, that does require a little more yak shaving than Cloud Run, but probably not as much as Fargate, so it's kind of in between. They also provide built-in MTLS, and they provide you what I call an application level service mesh. There's an open source project called Dapper, and that one is kind of given to you by default within Azure. So those are really the sorts of differences between the different kind of, yes.
I think there's one thought that one item that I think is missing is that on Fargate you won't be able to run a container that requires privileges, and they don't provide user namespaces or anything like that. So the kernel configuration of Fargate is very optimized and locked down. But in Cloud Run you can actually run any application even if it requires privileges. Previously you couldn't. But it's like, you know, in terms of opinion, Fargate is more locked down in terms of what you get, what version of Linux you get, what system calls your application can make, etc. On Cloud Run, you could run just about anything, and it could even create containers. You could actually run containerd in Cloud Run, or something like containerd inside a Cloud Run instance.
I'll take your word on that one, because I've never tried. You certainly can't SSH into those containers. You can't do like you can kubectl exec into a pod. You can't do any of that. And I must admit, I've never tried seeing how many Linux system calls I can make from my container. But you sparked my interest, so thank you very much. I should go and give that one a go. Yeah, so that's where we're at in terms of, so there are differences. Hopefully, I've kind of covered the main ones in terms of the level of yak shaving, opinionation, and so on that you can do with these different services. So for the last bit of this talk, what I'm just going to briefly go through is, as I said earlier, I actually took the Google have this thing called Online Boutique, which is like a demo microservices online shop application. And the reason I find it quite useful is because it's a bit more real world than standard Hello World container. So that architecture diagram there really is trying to show that it's got about 10 separate microservices. They're using a variety of technologies, Node, Java, Golang, Python, I think. And it uses a Redis data store. So when you go and look at the GitHub repo, it's all designed, these microservices are designed to be deployed onto a Kubernetes cluster. And I thought, okay, it'd be quite interesting to see, well, how easy would it be for me to port that over to Cloud Run in this case? Well, spoiler alert, it was pretty damn simple, and I was dead impressed. It did take a couple of days to do, mainly because I did have to make some code changes. And the reason I needed to do that is because the way that the microservices application has been designed is that it talks gRPC to the different microservices. And with Online Boutique, they use an insecure connection. And the problem is that Cloud Run doesn't allow insecure connections. It only allows HTTPS connections. So I had to change the code to tell it that if it was running under Cloud Run, it needed to use a secure client connection rather than an insecure one. So potentially, you've got code changes that you need to make, is what I'm trying to say. But that being said, apart from that, it was dead easy it was literally, that was the only change. And then I rebuilt the containers, and to be honest, that was kind of job done. I used Terraform to deploy all the services, and the reason I used Terraform is because that allowed me to also deploy the Redis instance via memory store, so I could do it all as one kind of Terraform script, if you like. What else? The service connectivity between Cloud Run and that memory store instance, that was very easy to set up. That's kind of more or less taken care of for you. And then finally, the last thing I want to say, certainly about Cloud Run, is that it doesn't support the idea of config maps. But what you can do instead is you store everything in Secret Manager, and then the integration between the Cloud Run instances and Secret Manager is just a piece of small amount of YAML configuration. So that's really how you do that, is you put all of your configuration into various Secret Manager items, and then you can use those either as kind of volume mounts, or you can use them as environment variables within your Cloud Run instance. Cool. So really this comes to a kind of end of my talk. So what I've gone through is hopefully now you've got a very good appreciation about these different serverless container hosting platforms and how they can genuinely be viable alternatives to running containers on Kubernetes. And I think the other takeaway, or the main takeaway I want to provide you with is that as well as being viable, they, I think, in my view, are going to be considerably cheaper to host those containers. Not necessarily from a billing perspective, because all of these have, frankly, quite complex billing mechanisms. Cloud Run gives you quite a substantial free tier, which makes it quite difficult to figure out how much it's actually going to cost you. But I think the more important part of figuring out the costs of running these things is actually the total cost of ownership, which needs to cover the toil effort involved. And that, for me, is where the biggest kind of benefit is. I don't know whether you use Kubernetes, how many clusters you've got, but it takes an enormous amount of business as usual platform engineer time to keep the lights on with Kubernetes clusters. And clearly, the more clusters you've got, the more effort and toil work's involved. And that is where I think the substantial savings can be made. Okay, so that really brings me to the end of my talk. Thank you very much for listening. We've had a few questions already, which was awesome, so thank you very much for your participation. If anyone's got questions, I'm happy to take them now, or I'll be around for the rest of the conference. And if you stick your hand up, I'll run down and hand you the mic.
Question? Yeah. Yeah, thanks for the talk and for the demo. I thought going from the sample set of applications, running that in Cloud Run was a good exercise to do. And you ran into the problem where you had to configure how the applications were using TLS, which wasn't expected in the original use for that example. I think another thing that sort of imagining a scenario where you were lifting and shifting a real Kubernetes deployment of real applications, what other kind of Kubernetes platform features might you be lacking in a Cloud Run environment or a serverless environment? One I thought of while you were going through was around maybe you would need to use Cloud IAM or some other type of permissions in order to control like what might be network policy or policy in a service mesh. But I just wondered whether there were any other things, sort of potential gotchas of people who weren't starting from scratch. They were actually starting from a Kubernetes environment and things that they might find that they were missing.
One that's probably close to your heart is policy engines, I would say. So you don't really have the concept of admission controllers with Cloud Run. So unlike, let's say, in Kubernetes, where if you're familiar with Gatekeeper or Kyverno or something like that, you can set up policies to basically allow or disallow certain images or containers or pod specs to be deployed into your Kubernetes cluster. You don't really have that ability with Cloud Run. So if you're using a GitOps approach and you put the right manifest into the Git repo, then it will just be created as a Cloud Run instance. So I think that's one that's off the top of my head. Mutual TLS, you'd need to do that, certainly with Cloud Run, you'd need to do that in the application layer. That is, by the way, possible. So I didn't really talk about this with the online boutique, but the code changes that I also made was that I ensured that if you've got two Cloud Run services that need to talk to each other, then you can do it in a kind of anonymous way. So that's just straightforward TLS. But you can also, using IAM, specify which Cloud Run service can talk to which other Cloud Run service, and you do that via the service accounts under which those Cloud Run services are running. So best practice is each Cloud Run service uses its own service account, and then you can explicitly state that service A service account can talk to service B service, but not the other way around. So you can start to do that kind of network traffic policy, I guess you might want to call it. So it is feasible, but it just takes a slightly different approach than you might be used to with Kubernetes. You don't really have the concept of namespaces in Cloud Run. You put stuff into regions and then forget about it. So again, you might want to think, if you had a multi-tenant kind of scenario, you'd probably want to split things by project, I think. So those. Yes. So yes, cross-project IAM for sure. And it looks like I need to stop. So thank you very much for your participation. Really appreciate it. And have a good rest of conference. Thank you.